Hi Geometry. This is Unit 5, Lesson 3, and page 532 in our workbooks. So we are going to talk about a rectangular pyramid. So if you would attempt to draw a rectangle and have a point up above, I realize it looks a little bit like a parallelogram, but this is my rectangle sitting on top of a desktop. And I'm going to attach each of the vertices to kind of create this pyramid shape. And this pyramid is made up of a rectangle that's the base on the bottom. And then if I wanted to cut this pyramid at any point, I would have other rectangles inside of this. These rectangular cross sections are what we were looking at in the earlier parts of our book, all the way up to the point on top where I don't have a rectangle anymore. My rectangles have decreased in size until I get to a point. So my original rectangle, the red one, is the one where my scale factor is a 1. That's my whole shape. And I'm going to make it smaller. I make it 3/4 smaller. So it's 3/4 as big. So it's a fourth smaller. It got the blue one got a little bit tinier. And then the green rectangle that you can see, that one's half the size. It's half as big. And then finally, I have my yellow one. My yellow rectangle at the top is 1/4 as big. And then I get where it's smaller and it goes down to a point. So if I look at these rectangles, and we'll start at the bottom of the page, and we'll create 1, 2, 3, 4 spots to do a little bit of math, where we have our original, our k equals 1, our original rectangle will be here. So let's draw our original red rectangle that's at the bottom, and I'm going to give you some measurements for it. I'm going to say it's 20 centimeters by 12.5 centimeters. That's my original rectangle. And then we moved up to my blue one. My blue one, my scale factor is going to be 0.75 or 3/4. And so my new blue one, I can find its measurements using the fact that we learned earlier this year that my new perimeter, or my image perimeter, or my image length, or a side length, the new length, the image length, is equal to the scale factor times the original. So I'm going to use that here. So then my new length would be 0.75, that's my scale factor, times 12.5, and 0.75 times 20. That's what I would multiply on my calculator to get my new measurements. And you'll see that you get 9.375, and you get 15 for the length. So now let's do the green rectangle. So the green rectangle is half as big as my original. So let's draw him a little bit smaller. That may not be very drawn to scale. So I've got my little green cross section. So let's calculate those lengths. Again, that's going to be my scale factor. My image is going to be my scale factor times the original, so 12.5, and my scale factor times the original. And so when I do that, I get 6.25 and 10 centimeters. So this is 6.25 in length, and this is, or in width, and that is 10 centimeters in length. So let's keep going with my yellow one. My one that my scale factor is 1/4. It's 1/4 as big. And so I've got my little yellow one towards the top of my rectangular pyramid. And when I take my scale factor times my width of 12.5, and I take my scale factor times my length of 20, I come up with 3.125 and 5 and 3.125. So these calculations are how I find my new length, which would be, or my new width. I multiply by the scale factor. and I find my new one. So let's write that down here. Image length, one more time because that was important, is equal to k times the original. So if I wanted to find the length or the width, I simply multiplied by my scale factor. So let's fill in up here with our numbers real quick. I'll pause this. We're going to put each of our widths and each of our lengths up above in the table. Okay, I hope you filled in the table up above like I have. So let's calculate our area. Remember, the area of a rectangle is base times height. So I'm going to go through and multiply my length times width, base times height. I'm going to go through each of these rows and I'm going to multiply them. I'm going to pause this video, you do the same, and then come back and let's make sure our answers agree. So check the 4 values I found for the area of my rectangles in my rectangular pyramid and see if we agree. So here's the interesting part of area. You might think area changes by the scale factor, but it doesn't. So for example, if I could highlight my original area, which is 250 centimeters, we all know that 1/2 of 250 is 125. But if I look at the area when my scale factor is 1/2, my area is not 125 centimeters squared. So this brings us to what we are supposed to see in this particular activity, is that my area is not changing by the scale factor. I don't multiply by my scale factor. I do multiply by my scale factor squared, actually. So going through this, my area is equal to my image area is equal to the scale factor squared times my original area. So that's a little different. Let's see how that works here. So for the blue one, for example, if I did 0.75 squared on my calculator and multiplied by 250, I would get the 140.625 you see up above in my table. So now let's do my 0.5 or 1/2 squared times my original 250, and you'll see that my answer is not 125, but it's 62.5 centimeters squared. So my area is not changing by the scale factor. My area is changing by the scale factor squared. And try it one more time for my 1/4. Square 0.25 and multiply by 250, and you'll find that you get you'll find that you get 15.625 centimeters squared. So the big takeaway, what you are supposed to notice here, what's really important, is that my scale factor changes, my area changes by my scale factor squared, and my length and widths just changed by my scale factor, as we learned earlier this year. You're going to learn that the volume in a later lesson, you're going to learn that the volume, just in case you're wondering, the volume is going to change by my scale factor cubed, by the way. That's going to come up in a later lesson. So let's take a look at the summary just real quick. So again, in this particular pyramid, because it goes up to a point, I know it's a pyramid, and the base is a triangle. So this is a triangular pyramid. And for example, my base is my original. And then every triangle is somewhat smaller. And maybe I think this red one is 3/4 as small, or 0.75. And maybe I think the green one is 1/2 the size of the original. And maybe I think this little one is reduced by a scale factor of 1/4. And then I get to the top, I get to a point, I don't have a triangle anymore. I just have a little bitty point. And so if you look at a triangular prism, as a reminder, triangular prism, a prism has 2 bases. So you have the original triangle on the bottom, you have a matching triangle on the top, and I connect my sides. This is a stack of congruent triangles. Each cross section inside here is a triangle of exactly the same size as the base. However, when you have a pyramid, then I have my stack of triangles dilated from my original scale factor of 1 to my scale factor of 0. That's my pyramid versus a prism. Thank you.